Okay, so for today, we are moving into the equations portion of our unit. So like I told you guys before, we are splitting the unit up into several parts. You guys did part A, finished up part A this week with expressions. Now we're doing part B, which is the equations. We're just going to do a quick review over what you should already know from last year, which is solving simple one-step and two-step equations. And they're all in linear equation format, meaning that they can create what we call a straight line if it was to be done graphically. And it's all through a single variable. Yes, there are equations that are in multiple variables, which we will hit into that a little bit later. Not this semester, but possibly at the end of the second semester with systems of equations. So what we're doing right now, again, is just a quick review over that one-step and two-step process. You guys have been dealing with equations since you were in kindergarten. You just didn't know that they were called equations back then. You knew it as you started with 2 apples, and then you picked up some apples from the store, and you now have 7 apples. How many apples did you pick up from the store? You knew it as kind of like a subtraction problem in sense, but really it's an addition equation problem where you have an unknown value. Sometimes you might have even been given a box and you're adding something to that box to equal 7. What would you have to add with 2 in order to get to 7? You guys understood that. Well, now we've replaced it with variables. So variable being an unknown value, a missing value. We also have the discussion of inverse operations. It's really important to understand inverse operations means opposite. So let me go ahead and key that in here. When we see the words inverse, this is another way of saying opposite. But they tend to say inverse, not opposite. Okay, and then we have inverse operations for addition, happens to be subtraction. So the opposite of addition is going to be subtraction. The opposite of subtraction is going to be addition. If I started off with a value, like let's say I started off with the value 3, and I were to add 9 to it, and then I were to subtract 9 from that, my final answer would just be 3. It's because adding 9 and subtracting 9 have an undoing sense to them. They are inverses to each other. They undo each other. Same thing for multiplication and division. With multiplication and division, they are opposites of each other. If I started off with the value 9, and then I went ahead and I multiplied it by 2, but then I divided it by 2, I would still have 9 left as my answer. So multiplying by 2 and then dividing by 2 has an ability to just cancel each other out, okay? Because it becomes a value of 1. And anything times 1 or divided by 1 is just going to give you that same value back. So the goal is to identify what the current operation is and do the inverse of that. You're identifying what operation is being presented in the problem, and then you're doing the opposite or the inverse of it. So for problem number 1, I see that this is what kind of operation right now? Multiplication. This is multiplication. So I want to do the inverse. What's the inverse of multiplication? Division. So in order to isolate my variable, I'm going to divide both sides by the 5. I'm not going to divide by 30. I'm going to divide by 5 because I want x to be isolated. 5 divided by 5 now creates a coefficient of a 1, but do I have to write the 1? Nope, it's an invisible math. So I'm just left with 1x, or just x, and then I'm going to do 30 divided by 5, which is going to come out to 6. So I get x is equal to 6. Okay, for problem number 2, what operation do I see presented here? Fatima? Subtraction. So what is the inverse, guys? Addition. Our inverse operation would be to add. So I want to go ahead and add 8. Instead of subtracting 8, I'm going to add 8 so that I can go ahead and cancel them out. And then if I did it to one side, I have to do it to the other side of my equal sign. So I'm adding 8 to both sides, and I'm going to get that x is now equal to negative 7. Okay, looking at problem 3. What operation do I see being presented here with the x? What operation is that? Asia? Is Asia? Is Asia not here? I was just doing random calling. Is Asia not here? Oh, no, you are. So why aren't you answering? Huh? Division. That's division. We have a division problem right here. So the inverse operation, instead of dividing by 4, we're going to multiply both sides by 4. Okay, instead of dividing by 4, we're going to multiply by 4. So I'm going to cross the 4's off. It creates that coefficient of a 1, that invisible math. And then 1/2 times 4 is going to equal 2. So we get x is equal to 2. Okay, for problem number 4, m minus 8 equals negative 3. So we've got that subtraction. What is the inverse going to be, Montserrat? What's the inverse going to be? Addition. So we are going to add. We're adding the 8 to both sides. Subtracting 8 and adding 8 are going to cancel each other out. And we're going to get m is now equal to a positive 5. Okay, I want you guys to go ahead and finish off problems 5 through, I think, 10. Yeah. Go ahead and do 5 through 10 on your own. All right, let's go ahead and go over these really quickly. So for problem number 5, we are going to go ahead and subtract 7.2 from both sides. That's going to cancel out the addition and subtraction of 7.2, and that leaves us with x equaling 1.7 for our final answer. For problem number 6, we have 3/4 x is equal to 9. 3/4 x is equal to 9. Technically, the inverse operation is going to be division because it says 3/4 times x. That 3/4 times x is going to have a division as its inverse operation. But when we divide, so if I'm saying, hey, I'm going to go ahead and divide here by 3/4, that's going to go ahead and simplify this to a 1. But if I divide 9 divided by 3/4, it's really like multiplying by the reciprocal. You're actually going to be multiplying 9 by 4 over 3. Doesn't really matter though. You're going to have your calculator. You can still type in 9 divided by 3/4, or you could do 9 times 4/3. You're still going to get the same exact result, and that's going to come out to equaling 12. X should be equal to 12 in this case. Okay, let's go ahead and flip it on over to the back. Problem number 7, we see that r over negative 2 is equal to negative 11. That means our inverse operation is going to be to multiply both sides by the negative 2. Okay, one of the biggest mistakes that people make is that they only focus on the number and they forget to focus on the sign. When it's multiplication or the division, the sign must be included. If it's addition or subtraction, you're obviously doing the opposite of that sign. So we're going to divide both sides, multiply both sides by a negative 2. You should get r is equal to a positive 22. You should get a positive 22. Here we've got x minus negative 3 is equal to negative 8. So instead of subtracting a negative 3, we are going to add a negative 3 to both sides. We are going to add a negative 3 to both sides. So subtracting a negative 3 and adding a negative 3 is going to have an inverse effect on each other. And you're going to get x is equal to negative 11 for problem number 8. Okay, for problem number 9, again, we've got 4/9 x. 4/9 x is multiplication, so that means that we need to go ahead and divide both sides by 4 over 9. But again, when we divide by a fraction, it's really the same thing as multiplying by the reciprocal, so it's kind of like doing 20 times 9 over 4, which would then come out to being 45. Oh, wait, no. Yeah, 45. Okay? And then problem number 10, when we got problem number 10, we've got x over negative 4. X over negative 4 is division, so therefore we're going to use multiplication. We're going to multiply both sides by negative 4. So that means negative 2.5 times the negative 4 is going to come out to a positive, and we're going to get a positive 10. Okay, any questions about one step? It's pretty simple, easy, straightforward. Okay, let's look onto the two steps. So the main type of two step that we're going to focus on is the ones that are written where you've got, a coefficient, a variable, and then a constant, and it's set equal to another value. So it's kind of in that format that we call ax plus or minus b is equal to c. So for here, what you would be doing with a two-step equation, the first thing that you focus on is the inverse operation to the constant. Okay, and remember the constant is the number that is held by itself. It's the number that is added or subtracted in an equation or in an expression. It doesn't have any kind of attachment to the variable whatsoever. It's an individual term by itself. And again, through addition or subtraction. So in this case, this minus 11 would be considered our coefficient, or sorry, our constant. So we always want to focus on doing the constant first, which basically means we're always doing the inverse operation of addition or subtraction first. Okay, then we go on to our inverse operation to our coefficient or our divisor. It could be a coefficient or it could be a divisor. That happens to be located right here. It's always attached, physically attached with the variable, either through a multiplication or it's dividing the variable. So then we focus on doing that inverse operation, which essentially means that we focus on multiplication or division second. Okay, so if I'm taking a look at this example here for problem number 1, we've got 2x plus 3 is equal to 23. My constant in this case happens to be that plus 3. So I want to go ahead and do the inverse operation to that plus 3 first. My inverse is going to be to subtract 3. And whatever I do to one side, I have to do it to the other. So I'm going to subtract 3 from my 23 as well. So my 3's will go ahead and get crossed off. I still have the 2x remaining, but now it's equal to 20 instead of 23. Then from here I can do my last step, which would be to divide both sides by 2. And I'd get x is equal to 10. For problem number 2, again, I want to focus on what the constant is. Which number up here is my constant? Which number is my constant? 5. Okay, that plus 5 happens to be my constant, so I want to do the inverse operation to that plus 5, which means I'm going to subtract 5. I'm going to subtract 5 from both sides of the equation. So I'm still left with x over 2. And then now negative 2 minus 5 becomes negative 7. What's the next inverse operation that I need to do, guys? Guys, multiplication. We need to multiply. Okay, so we're going to multiply both sides by 2, and we'll get x is equal to negative 14. You guys got to wake up. Okay, I know we're going kind of fast, but again, this should just be review from stuff that you already learned last year. This shouldn't be anything different. All right, let's go to the last page then. Anybody need this still? We're good? All right. So taking a look at problem number, actually I'm going to skip around. I want to focus on problem 5, or I'm sorry, not 5, 7. Let's go to problem 7. I want to look at that one. I want to skip around so that way I can give you guys everything to practice with. If I'm looking at problem 7, what number up here is my constant? The 5, right? What inverse operation am I going to do? Subtraction. Thank you. Even though you see subtraction in here, does that minus sign belong to the 5? No. So if I were to say, oh, I'm going to add, because I see subtraction, I'm going to add 5. Does 5 plus 5 cancel the 5 out? No. 5 plus 5 just makes it a 10. So now you're still stuck with another constant. Okay, you have to do the inverse of the constant, not of the operation. It's the constant's inverse. So the inverse operation to that constant, because of the fact that it is a positive, your inverse is to subtract it. So you're subtracting 5 from both sides. And those will cancel out. Now, what do I bring down? Nope. Negative 7x. That minus sign comes down like a negative, just like the 7x is going to come down. We did not get rid of that minus sign at all. That minus sign was attached to the 7x. So now it acts like a negative sign instead. Then we can do 19 minus the 5, which comes out to 14. From here, my next inverse operation is to divide. What am I dividing both sides by? Negative 7. We're dividing both sides by negative 7. And then x is equal to negative 2. Okay, be very mindful of those times when your constant happens to be written in front of the coefficient and variable. Be very mindful of that. I want you guys to do the rest of the problems on your own. I'm going to give you about 6 or 7 minutes and then we'll go over those. All right, let's take a look here at problem number 3. First thing that we're going to do is we are going to add 15 to both sides. Okay, that's going to leave us with 2n is now equal to a negative 14. We'll then go ahead and divide both sides by 2, and we'll get n is equal to negative 7. Okay, for problem number 4, first thing that we're going to do is subtract 8 from both sides. This was a positive 8, so we're going to go ahead and subtract 8 from both sides. That's going to leave us with x over 4 is now equal to a positive 9. We would then go ahead and multiply both sides by 4. We're going to get x is equal to 36. Okay, for problem number 5, we're going to go ahead and get rid of this 5 first. This is a positive 5, so therefore we're going to subtract 5 from both sides. Okay, that's going to leave us now with 15 is equal to negative 3y. That negative sign has to come down. That minus sign comes down like a negative sign. We would then go ahead and divide both sides by negative 3, and we would get that y is equal to negative 5. You could also write it as negative 5 is equal to y. Either one of those is perfectly fine. For problem number 6, the inverse operation to this negative 2 is a positive 2. So we're going to add 2 to both sides. That leaves us with a positive 4h is now equal to negative 4. We would then go ahead and divide both sides by 4, and we would get h is equal to negative 1. Problem number 7 we already did. Problem number 8, we're going to add 7 to both sides. That's going to leave us with 2/3 x is now equal to 8. We then would go ahead and divide both sides by 2/3. And that would give us x is equal to, what, 12? Okay. For problem number 9, we've got x over 5 plus 3 is equal to negative 8. We're going to subtract 3 from both sides. That's going to leave us with x over 5 is equal to negative 11. We then would go ahead and multiply both sides by 5. We'll get x is equal to negative 55. Problem number 10, we're going to subtract 6 from both sides. That leaves us with a negative 4x is equal to 20. We would then divide both sides by -4. We'll get x is equal to -5. Okay, our last two problems. Problem number 11. We're going to subtract 5 from both sides. That's going to leave us with 6 is equal to 3a. We would then divide both sides by 3, and we would get a is equal to 2, or you could put 2 is equal to a. It's okay. And then problem number 12. We're going to add 11 to both sides. We left with -4/5 w is now equal to 24. We would then divide both sides by -4/5. And you're going to get that w is equal to a -30. Yeah. That's just saying number 11. Number 11 is 11. That's just number 11.
Oh.
Just like this is number 10, number 9.
Oh.
Oh, did you guys think that was 11.11?
Yes.
Oh, I'm so sorry. I should have put a better space in there. This was me at 5 this morning. I'm sorry. I thought I had put a better space there, but I guess I didn't. My apologies. Okay. But that's an 11, not an 11.11. That's just question 11 is 11 equals 3w, or 3a. Okay, any questions? All right, you guys have lots of time to be able to work on a Delta math assignment. Remember, this is Thursday. That means that it is due tomorrow. All material from this week is due on Fridays. So make sure you're using your time wisely today to get through that Delta math.